What I have here is a simple three-dimensional model. It is representing two cameras that are mounted 5 feet apart from each other and both pointed in the same direction. 45 degrees to the left, I have 3 objects at 100, 1,000, and 10,000 feet away. They are all on the exact same line of sight with the camera on the left for convenience, and what we will be looking at is the parallax, the difference in the look angle from the camera on the right, whether the object is in the near field or in the far field. Obviously, this system works with objects in the near field better than in the very far field. It can be used to qualitatively, but maybe not quantitatively, judge distance with some accuracy. This first object is drawn as 50 feet in diameter to represent a tree, and this object is drawn with a diameter of 3 inches. And now you can see I have 2 lines that are going back to the camera on the right. These represent 1 pixel width with the assumption of a 4K camera and a 120 degree wide linear field of view. So every pixel is the same width across the entire view. The reality with a wide field of view is you're going to have distortions further out you get from the center of the field of view. So the pixel width is not necessarily a good judge. This is just an example. Here we have an object that looks like it's about 4 to 5 pixels wide. Again, this is drawn to be 3 inches wide. So a 3-inch object near the center of view, 100 feet away, is going to be about 4 pixels across. Now, if I want to take frames from 2 videos from those cameras where there is an object, I want to take the 2 frames at the same time and judge whether that object is in the tree or in the distance. There are 2 things I can do. I can take the fork of a branch of the tree and I can line up that fork so that I have 1 tree in both images. If I have 1 object, then the parallax places that object somewhere in the tree. If, on the other hand, I have an object over here, say about 20 pixels away, that object is 1,000 feet away in the distance. If it's 25 pixels, it's a much greater distance, 10,000 feet away in this model. The other thing I could do is I could take the frames taken at the same time, and I can overlap the 2 objects from each frame. When I do that, if I end up with 1 tree, then the object is in or around the tree, is very close to the tree. If I have 2 images of the tree that are not overlapped, but are 20, 25 pixels apart, what's going to happen is I'm going to see 1 object, but I'm going to see 2 trees, and that's going to tell me that the object is not in the tree. At 1,000 feet away, let's say the object is 1,000 feet away, and let's say I have an object that is 1 foot across, 1,000 feet away, it's going to fill up 2 pixels. Don't have a lot of detail in this, but you can see something is there. If I take the object from each frame taken at the same time in the videos and I overlap the two objects, what I'm going to find is that I have two images of the tree in parallax. One is over here, the other one is over here, about 20 pixels away. The object is not in the tree that's 100 feet away. If I go 10 times further out, the parallax doesn't actually change all that much. It's just a few pixels. But now I still have an object that is depicted as 12 inches across, and yet it's only a fraction of a pixel now. If I line up this object with another object in the other camera, that's going to be way over here. It's still only 20 pixels. But I'll see one object and I'll see two trees. And I know that the object is not inside the tree. Here's another thing that's important. An aircraft is probably going to be more than 1,000 feet away. Probably more than 10,000 feet away. The navigation strobe, or landing light, is a relatively small point of light, depicted by 1 foot across. Yet, what we're going to see in a picture taken at night is a bright light in a dark background. That bright light is going to occupy several pixels. It's not a good representation of the actual size of the object. And that's because the light is so bright that it is saturating the pixel that it occupies, and it is also flooding light into adjacent pixels. So the object's going to appear larger than it is because it's just a bright light at the distance. Whether it's your eyes or the camera, it's the same basic effect. And that is how to use a stereographic video to take a frame grab at the same instant and overlap the frame grab to try to judge the distance of an object, whether it's in the near field or the very far field. And there we go. Got it in one take. Yay!